Hi guys, welcome to Tutes Online. Today we'll be looking at differentiation by first principles. The basic concept of this is to find the slope of a tangent to a curve. To demonstrate this, we'll draw a Cartesian plane, where that's x, that's y, and we have some sort of shape like a parabola. So we want to find the slope of a tangent to this curve. So if we choose 2 points close to each other, and we say this and this point, if that's very close, say we're zooming in, we want to find the slope of that tangent. So this point we can label as x, and this point we would call x plus delta. This point over here and this point here would be y and y plus delta. Delta just means a very small number, so we're going just a little bit beyond our previous number. So we want to find the rise over run of that. So here we'll use different notation. We'll say that y is equal to f of x. So to find the rise over run, we can say that the rise would be the difference between this point and this point. That would be written in our different notation, fx plus delta minus our lower point, which is just f of x. And our run would be our furthest point, which is x plus delta minus our first point, which is minus x. Right away we can see that this can be written just as delta on the bottom. So we'll get rid of that, neaten it up. Now we'll get rid of our Cartesian plane. And we'll have to apply limit theory, because we want delta to get as close as it can to 0. So that would mean we'd want the limit as delta approaches 0. And this is what the integration would be. So we'll label that as f dash x equals. So that's our formula for differentiation by first principles. So if we apply this to a simple equation such as f of x equals 3x plus 1, subbing in this value into our equation, we'd find that this would be equal to the limit as delta approaches 0 of 3x plus delta plus 1 minus our other value, which is just 3x, put a bracket here, plus 1. And this is all over delta. So we'll say that's f dash x. So expanding those brackets, that would be 3x plus 3 delta plus 1 minus 3x minus 1 all over delta, which would be equal to limit as delta approaches 0 of, we can see that these cancel, these 1's cancel, so we're just left with 3 delta over delta. These deltas cancel, so we're just left with 3. And we know that the differentiation of 3x plus 1 is just 3. This method looked fairly simple, but if you try applying it to a more complicated equation like x squared plus x plus 1, you can see how difficult it will get. Whereas off the top of our heads, we can differentiate this equation and say it's 2x plus 1.